Chapter 8, Number 20. For an object moving along the x-axis, the potential energy of the frictionless system is shown as in this figure. Suppose the object is released from rest at the point A. Rank the other points in the figure according in increasing order of the object's speed and indicate size where appropriate. So we'll start with least speed and then the highest speed. Very important to understand that the object is only moving back and forth. It's doing this. Even though the graph has all these hills and valleys, that's not a picture of the motion. All right, that's just a description of the potential energy for some sort of systems, maybe a spring system or something. And what we look at here is we say, well, at the start, we have only potential energy because at the start, we are at rest at point A. And therefore, our energy, our total energy, is whatever our original potential energy was. In other words, since E equals U plus K, then the energy is going to be the potential energy at A plus 0. And that will stay constant. So it will basically be represented by that line. That's the energy of our system. Anywhere else, we'll invert that relation and we'll say that the kinetic energy anywhere is the actual energy that we have minus the potential energy at the point we're talking about. So here it would be, it's the difference between the graph, the blue line, and the graph. So really we're just looking for instance, where is that distance the least? And that distance is clearly the least here, where it's 0. So the least energy is G. And then if we look at our next collection, we see that B and D and F are all the same. At least they seem to be by I. And they are clearly, that's a smaller gap than either at C or E. So we're left with our next thing would be B or D or F, which I'm going to write by saying they're all equal. And then they are less than, and we say our next gap is clearly E is a bigger gap than B, but it's a lesser gap than C. So our order is for lowest kinetic energy is G, and then any of B, D, or F, and then E, and then C. And of course, since the kinetic energy is just a half mv squared, we can see that minimizing K minimizes V, and so on, that they go in exactly the same order. So this is also the order for energies as requested.